Okay, Janelle, this should help you out with these last two questions. This is checking the constant of proportionality here. Is it a proportional relationship? Remember, that is just y divided by x for every pair has to be the same. If it's not proportional. But the other thing here is that it also has to be, remember, a proportional relationship has to go through 0, 0. So when this table shows 0, negative 19, I know that's a no, because 0, negative 19 is not part of the proportional relationship. If x is 0, then y has to be 0. So that one's done. Okay. I'm going to skip down to C and go, okay, that has 0, 0. So that's maybe okay. But they also have to be y divided by x is the same. So negative 27 divided by negative 3 is positive 9. But negative 1,000 divided by negative 10 is positive 10, right? No, positive 100, sorry. Those are not the same number. As soon as you have two of them that are not the same, no, it's not proportional, because y divided by x is not the same. It doesn't matter what the other ones are, because they all have to be the same. So that leaves this last one. When you divide, now this I would use a calculator, right? Because it's 7 divided by 14. It's 3.5 divided by 7. But when you do those, you get 0.5. And if you actually check all of them, you get 0.5. So this one is a yes, because even though the numbers are funky, and again, you would change those to decimals, 40.5 divided by 81, they are all 0.5. So 0.5 is K, right? That's the unit rate, that's the constant of proportionality. So that's how you check that one. Now, let's go over to this page, because you said you had some trouble here. This is finding the constant of proportionality. The constant of proportionality is the unit rate, right? So again, it's still y divided by x. The key is we need to know what y is and what x is. Well, when we're talking about a time and distance, it's always usually distance over time. We want to know the number of meters per second that this runner can run, the skater can skate. So I'm going to do the harder one. I'll let you do the easier one. Okay, so I'm going to set this up and say this is, that doesn't all right, 1,500 meters in 106.43 seconds, right? This is the, if we put it in a table, right, the y and x, we're going to divide meters per second. So this would be the seconds, 106.43, and this would be, right, the meters. So the way I set it up is the way that we would divide it. 1,500 divided by 106.43, because that's turning the seconds into one. How many meters can this skater travel in 1 second? I have no idea what that is. So that is a problem that I would do with a calculator, which I'm doing right now. 1,500 divided by 106.43 is 14.09, blah, 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 blah. It goes on. So 14.09, good enough. Okay, so K is 14.09. That means our skater can skate 14.09 meters in 1 second. Okay, so that's how you set it up. Now, the runner 1A, it's the same meters and seconds. So set it up the same way, it's just easier numbers. Okay, the only tricky thing about this is knowing which one goes on top, which one goes on the bottom. And again, when it's distance and time, the time goes on the bottom.